earthquakes, volcanoes, floods, tsunamis, landslides. What if we can avoid the human loss caused by natural disasters? Guess what? SAR can.
But what on earth is SAR? SAR, or Synthetic Aperture Radar, is a radar system for ground observation with satellite as the carrier. It sends out waves and receives the reflected waves to calculate how much the ground has shifted with an orbit around the Earth. Whoa. Let's slow down a bit and go through this again. When you think of a satellite image, most people envision something like this. This is called an optical image, but there's another way to visualize the Earth's surface from a satellite. Instead of utilizing the light from the sun, as with optical images, we can actively illuminate the ground. How? By generating energy and transmitting it towards a target. Depending on the target properties, all, some, or none of this energy will travel back to this antenna. This technique allows the radar to see through the day and night, through sunny days and rainy ones, which is a good thing. But we're still stuck on one problem. See, to get better resolutions, bigger antennas must be built. In order to get a spatial resolution of 10 meters, you would need a radar antenna about 4,250 meters long. That's long. How could we go around this long obstacle? By synthesizing, which basically means giving the effect of a long antenna by adding up the reflections from many radar pulses on a target around the ground. And that, my friends, is SAR. It's worth mentioning that SAR has evolved into several species, one of which is interferometric SAR, INSAR, which maps surface deformation patterns by exploiting the phase difference between two complex radar SAR observations on the same area. Polarimetric SAR, PULSAR, on the other hand, sends waves in one specific direction and studies the direction of the returned wave, which guides us to electrical and geometric properties of the observed surface. Polarimetric interferometric SAR, POL-INSAR, is basically a mutant of the two mentioned earlier. Now that we've gone past the hard part, which I must say is impressive considering your even more impressive scientific knowledge, how does SAR become the superhero we've all been waiting for? SAR can observe ground displacement, where it can take an image acquired on one day and combine it with an image taken 12 days later on the same place, then compare both of them to see the motion of the ground. If the displacement rate is large enough to be a sign of, say, an earthquake, warnings will be sent to the endangered area to minimize the damage. SAR can also watch deformation and migration of magma in the surface near a volcanic edifice of all of our 1,400 lovely lethal grenades, giving us the chance to detect signs of possible eruptions. Add to that, SAR can monitor biomass and ice caps melting. Other ways you could die include floods, landslides, deforestation, which all SAR could help detect. Family of SAR is diverse. We got Sentinel-1 with ESA as its godfather, RadarSat with CSA as its guardian, ALOS-2 having JAXA as a parent, and the newest addition to the family, NISAR, the baby of NASA, and ISRO, scheduled to launch early 2023. It's a multidisciplinary radar mission to make integrated measurements to understand the causes and consequences of land surface changes. By the way, NISAR will be the first NASA radar mission to systematically and globally study solid Earth, ice masses, and ecosystems. This family will make sure you sit on your couch having in mind that your ceiling won't be tumbling down on your head without you knowing so. Unless you wanted to.